All right, let's take a look here at closure 151. A spring is hanging from the ceiling of a room. It is pulled and released so that its distance from the floor with respect to time can be modeled using a sinusoidal function. All right. So at 2.5 seconds, the spring is at a minimum. At 1.5 feet, at 3.75, it's at a maximum 6 feet. Write an equation that models the motion. So I would, of course, recommend a graph. And we just want a first quadrant. Looks like we're going to have all positive y's. Our low is 1.5. Our high is 6. At 2.5 seconds, we're at the low. At 3.75, we're at the high. There we go. So using symmetry, 1.25 later, we're going to be at another high. That looks like that's, or at another low. And so using symmetry, our period looks like it's 2.5. So we'll actually be at a low here too, won't we? It means we'll be at a high at 1.25. There we go. Sweet. So that would be the middle of 6 and 1.5. So 6 plus 1.5 divided by 2. 7.5 would be 3.75. That's our midline, or our vertical shift. Let's go with our amplitude. That would be 6 minus 1.5 divided by 2. And I think that is 2.25, which makes sense because if I go 3.75 plus 2.25, I get to 6, and minus I get to 1.5. Good. And then let's go period. Period we said was 2.5, so we use our PB equals 2 pi to determine that our B value is 2 pi over 2.5, and I would prefer we maybe multiply that by 2 over 2, we get that 4 pi over 5. That would be ideal. And because it's starts at the bottom, we can just call it a negative cosine. So let's go here. Y equals amplitude of negative, well, amplitude is 2.25, but we're calling it a negative cosine, with a B value without a shift of 4 pi over 5x plus our 3.75 midline. Check on the calculator, but I think we're good.